So let's get started. This is going to be part 2 of finding duplicates in an array. The part 1 is there in the description. Please go and check that out. It is a continuation of part 1. Okay, in part 1 we had taken a look at what mapping, we looked at solving this problem in a conventional method. For that we had used a mapping object, and so this mapping object will contain the keys from each of these arrays. Each of these numbers are going to be the key and the value would be the count, and that is the approach we followed. To have a better understanding, I would recommend go and look at part 1. It's there in the description. So as part of part 2 of this problem, we will be looking at solving this at a space complexity less than O of n. So the problem here was when you have a lot of elements, your space complexity also increases. This algorithm that we are going to follow will make sure that the space complexity is as low as possible. Okay, so let's take a look at this question in detail. Given a read-only array of n plus 1 integers between 1 and n, find one number that represents a linear time using less than O of n space traversing the stream sequentially O of 1 times. Okay, so basically if you look at this example here, the size of this array is 5 because there are 5 elements. So according to the question, you are not supposed to have any element more than 5. It has to be less than 5. So that is what you see here. 1 till 4 you have numbers. Here the number 2 is missing, 4 is repeated twice, 1 is repeated twice. Correct? So that is what they are saying. You will have one number, at least one number which is a duplicate. Okay, and you will not cross the number elements in this array will not cross the size of this array. Okay. Alright, so this is one point we have to keep in mind before we move on to the algorithm. Right. So all of you would have heard of something called the linked list. Right. Now, linked list is basically let's say we have a set of numbers 3, 5, 6, 7, 8. Okay. So all of these numbers are going to be linked to each other. Not all of them. So it forms a chain. Right. Let's say 5, 3 to 5, then 5 to 6, 6 to 7, 7 to 8, so on and so forth. Right. So this is a linked list. So it's got the for example, if you look at 8, it has got a link to the previous number. It knows what the previous number is. So that is a linked list. It follows a list which is linked to each other. Right. Now there is a concept called circular linked list. What does that mean? So let's say we have a number here which is 10. Okay. Now this 8 is connected to 10. Let's say 8 is connected to 10. Right. So, alright, bear with me when it comes to representing it. Okay. Right, this is the best I think I can do here. 8 is connected to 10 now, and let's assume 10 is connected to 6. Okay, it's linked to 6. So now what has been found here? Look at this. 6 is connected 7. 6 is connected to 7. 7 to 8. 8 to 10. 10 to 6. Right. So here, when the minute you reach 6, again you go back to 7. So you've got a circular relation here. Right. So this forms a circular linked list. Okay. Such a pattern forms when you've got duplicate items in the list. Let's say in case of arrays, if you're linking these things, if you've got duplicates, you will have a circular pattern being formed. If the minute you get a circular pattern, that means you've got a duplicate number in that array, and if you're trying to link all these numbers. Alright, now what our intention is to find what is that duplicate number. What you know that there is a duplicate number the minute you've got a circular relation, but we need to find out what number is being duplicated. So that if you want to find that out, you have to find the starting of the circular linked list. The starting point, that is 6. This is where the circular linked list began, right? Up until that point, it was a linear linked list. 3, 5 was a linear linked list. And starting 6, it became a circular linked list. So 6 is the starting point where the circular linked list began. Okay. Okay, guys. So let's look at how we can understand the formation of linked list and circular linked list. Okay. So we know the concept that if you've got a circular linked list, that means there's a duplicate in the array. You've got a duplicate number. Alright? Okay. To form the circular linked list or the linked list in general, you need 2 pointers. To find the particular element that is actually, responsible for forming that circular linked list, you need to follow this approach, okay, where you have 2 pointers. One is the slow pointer represented by S, and then you have a fast pointer represented by F. Slow pointer, you will move one node at a time, okay, whereas fast pointer will skip one node, so it will move 2 nodes at a time. Right? That's a difference. This is one thing you have to understand. So one node at a time, meaning what does that mean? Let's assume that both slow and fast pointer is at this equal to position. So slow pointer will, so in the first iteration, slow pointer will be at 2, whereas the fast pointer will be at 3. The second iteration, slow pointer will be at 3, fast pointer will be at this position, the second 3. That's how it's skipping one node, whereas slow pointer will move one at a time. Alright? Okay, this is one thing you have to keep in mind. Second thing that you have to keep in mind is when you are actually going to a particular node, right, we will not consider the absolute value. Okay, rather we will consider this number as the index. Okay, we will consider this number as the index, and then we will move. Let me give you I'll show you how it works. Okay, let's assume that both slow and fast pointer is at 0. Okay, both are at 0 initially. Okay, so slow has to move one position from this 0. Okay, so how it moves is that 0 number is considered to be the index. Okay, so it will be ARR. So slow pointer will move like this, ARR of 0. Okay, so this number is considered as the index, ARR of 0. What is there? What is the value at ARR of 0? It is 2. Correct. The ARR of 0, the value at ARR of 0 is 2. So initially, during the first iteration, the value of the slow pointer will be 2. Okay. What is the value of slow pointer in the second iteration? It will take this value and it will put this number 2, it will consider this as the index. So in the second iteration, slow pointer will be at ARR of 2. Okay, this number which it got will be considered as a part of the index and it will get the value from that array. So ARR of 2, what lies in the second index? 0, 1 and 2. So you get 1. Meanwhile, what happens in the fast pointer, in case of the fast pointer in the first iteration? It has to skip two nodes. It's starting from 0. So it will be ARR of 0. Okay, this is the first node. It has to skip it again. It has to skip 2. So ARR of 0. So ARR of 0 is going to be 2. Correct? This value is 2. So ARR of 2 is what? 0, 1, 2. This whole thing is going to be 1. So basically your F skipped 2 and reached 1. Right? So F is going to be 1 in the first iteration. Whereas in the second iteration, the same thing follows. ARR of 1, okay, because 1 is the value currently here. Now it has to skip 2 nodes. ARR of 1. ARR of 1 is what? What is the value at the first index? 0, 1, 3. So ARR of 1 is 3. Now ARR of 3 is what? What is the value of the third index? 0, 1, 2, 3. The value is 3. Okay, so in the second iteration, F is going to be 3. Now, slow pointer. What is the value of slow pointer? ARR of 1. In the third iteration, slow pointer will be ARR of 1. ARR of 1 is what? 0, 1. It is 3. Okay. Now, what is F? F is going to be ARR of, let's take a look at it, ARR of 3, and that again will become the index of what you're going to search. So ARR of 3. So ARR of 3 is what? 0, 1, 2, 3, 3. So you got 3. ARR of 3 is again what? 0, 1, 2, 3. Again you get 3. Right? So now at this particular point, after third iteration, the value of S and value of F is the same. S is equal to value of F. This is where you will stop. This means you have reached a circular list, right? Circular linked list. When both S and F are the same, that is the point you will stop, because you have reached that circular linked list. How is the list forming? Look at this. You have, if you want to understand it in the list form, 2 is connected to 1. Look at the slow pointer. That makes sense because it doesn't skip anything. 2 is connected to 1. 1 is connected to 3. After 3, what will be the value? ARR of 3. ARR of 3 is what? 0, 1, 2, 3. ARR of 3 would be 0, 1, 2 and 3, right? ARR of 3 would be 3. This is connected to 3, right? So 2, 1, 3, 3. This is how the relation is, right? So if we have to form the circular pattern, it is going to be something like this. Okay, so your circular pattern is formed here. Look at this. This 3, this value 3 is being looped over and over. This is your circular pattern. This section that you see here, this section, this section that I've selected is the circular pattern. 3, it goes to 3, it goes to 3, it goes to 3, goes back to 3, again it goes back to 3. So this forms a circular linked list, right? So slow will move like this. It will go to 2, it will go to 1, then it goes to 3, then it goes to 3 again, and it goes back to 3, and again it goes to 3. Okay, whereas fast, how does it go? It skips 2, it will go to 1, okay, then it will skip this 3, it will go to the next 3 that you see here, okay. Next, it has to skip this 3 again, and it will come back to this 3 itself. So it's going to skip this 3 rather than slow, which follows, it comes to this 3. This never happens in case of fast. Fast will remain at the selected 3 always. Okay, and whenever the slow pointer and the fast pointer is equal, that means you have reached a circular linked list. That is how you will get to know that there is a duplicate. And what does a circular linked list mean? Circular linked list means there is a duplicate. Right? Fine. Let's take a look at it with another example. Okay. So let's take a look at the slideshow. Right? We have the slow and fast pointer indicated here. Okay. So initially the value of the slow pointer would be 2, because array of 0 is 2. Fast pointer would skip one node. So array of 0 is 2, array of 2, 0, 1, 2, array of 2 is 4. So fast pointer is at 4. Now check how it goes. Slow pointer would be at 4 next. Slow pointer would be at 1, but fast pointer initially started off at 4. It skipped 1 and it will be at the next thing, that is 3. Right? Now let me finish and you'll understand how it works. Slow pointer went from, in the first iteration it was at 2, second it was at 4, third it was at 1, whereas fast pointer in the first iteration it was at 4, then it was at 3, and then it became 1. So in the third iteration, both slow and fast pointer reached one common meeting point. Right? At that point you will know that you have got a circular linked list. Okay, so we've understood this, we've got it. Now the next thing that we have to do is we have to find that point from where the linked list started, the origin of that circular linked list. The origin of circular linked list is 4, because that is where the linked list became circular. After 4 it went to 1, then 3, and then got connected to 4. So the origin is 4. If you can find the origin, that will be your duplicate number in that array list. So once you found the common meeting point, the next thing you have to find is the origin. So to find the origin, it's very simple. Currently, whatever the slow pointer is, wherever the slow pointer is pointing, let it remain at that position itself. So slow pointer is at 1. Okay? Now the fast pointer and the slow pointer both are at 1. What we are going to do in the next step is, slow pointer remains at 1, whereas fast pointer will be reset to 0. Okay, the fast pointer will be reset to 0. Now we will follow the same iteration till both slow pointer and fast pointer meet. But in this iteration, the logic that we will apply is, both slow pointer and fast pointer are supposed to move at the same pace. That is, it will move one node at a time. Right? Just like the slow pointer, even the fast pointer will go from one node to the next. It will not skip. Okay, that is what we will do to find the common meeting point. We'll understand it better when we start coding. Okay, so look at this. Slow pointer is at 1, fast pointer is at 0. It is a reset. Now slow pointer, in the next iteration, slow pointer becomes 3. Fast pointer will become 2. Right? It is not going to skip a node. It will follow the same slow pointer space. And the second iteration, slow pointer is going to be 4, and fast pointer will also become 4. Now slow pointer and fast pointer both are same, which is 4, and that is where you will get the meeting point, and that is the origin of your circular linked list. That will be your duplicate number. When you start writing through the code, you will be able to understand it better. Let's look at another example, slow and fast. I'll just walk you through it really quick. So slow is at 2, fast is at 4 because it skipped the first node. Slow is at 5, fast is at 4. Now where is the meeting point? Meeting point is 1. So slow went from 2, 4, 5 and 1. Fast skipped 2, it became 4, 1, 4 and 1. That is where the meeting happened. Now we found the meeting point. Slow will remain at 1, fast will be reset to 0. So slow will follow the same iteration pace. Slow will become 3, fast will become 2, slow will become 4, fast will also become 4. That is how you will find the origin of your circular linked list, and that will be your answer. You'll understand it better when we start writing the code. Okay, now let's take a look at how to code this. We looked at the theory of it. Now let's look at how to code this. So we've got 2 pointers, slow and fast. So let's create variables. Let slow is equal to, it starts off from a of 0, starts with 0, and fast pointer is going to skip one step, right? a of 0. Okay. Now we will keep looping, we will keep searching, and this iteration will go on till we find a common point. That means till we find the circular linked list, right? So till slow pointer and the fast pointer is not equal, you will keep iterating. Okay. So now what will the slow pointer be? It will skip, it will go to the next node. So a of slow. And what would the fast pointer be? Fast pointer will skip one node. So it will be a of fast. Okay. And when both of them are equal, we found the circular linked list, and what will we do? We will reset the fast pointer to 0, and we'll again iterate through the whole list. Slow is not equal to fast, right? As long as it's not equal, you keep iterating, and the value of slow pointer will move one step at a time, the same pace, right? But the difference here is, in this iteration, fast pointer will also follow the same pace as the slow pointer. So fast will also move one step at a time. It will not skip the node in the second iteration. Okay. So fast is equal to a of fast. And now what do we do? If both of them are the same, we found the meeting point, and that is the origin of your circular linked list. When you find the origin of your circular linked list, that is your number. So we can return either slow or fast because both are the same. Return slow. Now let's try running this. Alright, test. And you can see the test has been succeeded. Let me submit my answer and let's see what we get. It's a correct answer. And this approach, for this approach, your space complexity is 1, O of 1, because you're having a constant space. Where and all have you used the space? The space is being used for slow and fast. Correct. These are the two variables where these are the only two variables that are created, right? and this will just store one value. So your space complexity is big O of 1, it's constant. And this is the most optimal solution for such a problem. Any questions, feel free to comment down below, guys. Thank you.